Okay, well, we want to go on to this idea of log base E. Before we do that, we have to understand E. E is the limit as n goes to infinity of 1 plus 1 over n raised to the n. Now, we haven't talked in here about compound interest, and my experience is that doesn't get talked about much in secondary schools, which is a little unfathomable because you have a personal finance class in the schools in this county, and it's required for graduation, but depending where you went to school, maybe not. But this seems like something that would be obvious to talk about, but maybe not. So, anyhow, let's make the connection between this and compound interest, or at least let's begin to make the connection, and then we'll complete it. Okay? If you have $1,000 at 10% annual interest, what does that mean? It means if I give you $1,000 now, at the end of a year, you'll have that plus 10% of it. So after 1 year, you would have $1,000 plus 10% of $1,000, and 10% of is the same as 0.10 times. And if you don't know that, make sure you review percents. It wouldn't take long. It's something that you've certainly understood and maybe just need to review. But anyhow, we have then, if we factor out the $1,000, we have 1 plus 0.10 times $1,000. Now, you might ask, why would I bother doing that when I can easily calculate this? It's because we want to generalize this, and this is going to give us something to build on, as you'll see. So make sure we understand this, because we're going to build on it. Okay. Again, factor out the 1,000. You have 1.10 times 1,000. And 1 plus 0.10 is 1.10. Multiply that by 1,000, you get the 1,100. It works. And it's something that's going to allow us to understand this here in just a couple of minutes. Now, if we compound annually, how much do we have in 40 years? Well, compounding annually means we calculate our interest at the end of every year based on how much money we have at the end of the year. That would be opposed to simple interest, where you just say, okay, 40 years, we're going to get to add $100 40 times, because that's what we add with simple interest. And you'd end up with $5,000, as you can easily verify. $100 for each of 40 years, you get $4,000, add that to 1,000. Well, nobody wants to do that. You at least want to calculate your interest based on how much you have at the end of the year. So that's what we mean by compounding annually. That's what we do. Now, if we do that for 40 years, it's the same as multiplying by 1.10 40 times, isn't it? Because every time you add the interest, you multiply your principal by 1.10. So you end up with $1,000 times 1.10 raised to the 40th power, because multiplying by 1.10 40 times is the same as multiplying by 1.10 raised to the 40th. And I estimated that would come out somewhere around $50,000, cheating and using the rule of 72. And that wasn't too far off. Actually comes out closer to 45,000, 45,200 something, I think somebody told me. Okay, now, we can do better than that, actually. We can compound semi-annually, meaning we add half of the 10%, that would be 5%, but we do that twice a year. So we take our 10% interest, we split it into 5% chunks, and do that twice a year. Means we add 5% twice a year. Okay, adding 5% is the same as multiplying by 1.05. Well, then after 40 years, you would multiply by 1.05 twice every year. That's 2 times 40 times. So you would have this times $1,000. And y'all figured that out. What did you come out with?
49,000.
49?
Yeah.
Yeah, 49,000 what? Okay, so this gives you about 49,500. And there's change with that, and you want to calculate that, but just getting an idea. So we go up from a little over 45,000 to, about halfway between 49 and 50,000. That's $4,000 plus, just by compounding semi-annually. So at the end of 40 years, you'll be glad to have that little extra change, if money's worth anything in 40 years. Okay? Then, using just, we could rewrite this expression using just our 10% figure, and we would write that as 1 plus 0.10 divided by 2. because, again, we're dividing our 10% into two pieces. And 0.10 divided by 2 is 0.05, so this would be the same as this. Okay? Then if we compound monthly, well, it becomes pretty clear that we're going to divide our 0.10 12 times and do that 12 times every year. And what do we end up if we do that? 53.7. Now that's actually, I think, just a little less of a boost than we got going from annual compounding to semi-annual compounding, just by $100 or so. But it's a little less of a boost. And I predicted that the boost you got going from here to here would be less than the boost you got going from here to here. I was almost wrong. Okay. I thought it would be. I didn't think it would be that close. I knew you'd get a pretty good chunk here. Okay. Well, then, if you compound n times annually at rate r for t years, you end up with a principal function that's equal to your initial principal, p sub 0, times 1 plus r over n raised to the nt. R being your interest rate, which in this case would be 10%. But this will apply to any interest rate for any number of compoundings in any initial principal. Okay, so if we do this, if n is 2, that means it's biannual. You take your 0.10 divided by 2 times 2t, right? T's 40 years, 2 times 40 years, and all that. Okay, there's your general formula. Continuous interest, you increase your number of compoundings beyond all limits, beyond all bounds, and you get continuous interest. Better than 12 times a year, better than daily, 360 times a year. We round that off to 360. That's what banks do. And it's perfectly kosher. Or every second, and don't ask me what that number is. 30 million. And I forgot what the question was because I was busy with the numbers. About 30 million seconds a year. Okay, so n would be about 30 million. Okay, well, you take the limit as n approaches infinity and you get this. Because E is defined as this. We haven't completely made that connection, but that's what it is. Okay? And when you evaluate that, what did you get?
54,600.
54,000 what?
600.
Okay, so that would be 54,600. Not that much of a boost over this. So you would think that going to continue, compounding every instant, it would boost it more than that. You'd still take it. That's 900 extra bucks or so. Okay? And it is a significant difference over 40 years. You'd probably be able to go out to dinner with that. Okay?